Let's look at an example. This example, we have a concave mirror, so we're going to go ahead and draw those little lines there. There we go. There we go. And we have an object that is placed in front of it. So let's just follow the steps. We draw the mirror. We draw the focal length is 10 centimeters. So I'm going to draw it right here. I'm going to have those 5 squares be 10 centimeters. That's going to be the focal point here. That means that the center of curvature is right here. And then we draw our object. It says that the object is 30 centimeters in front of the mirror. Since each of these are 10 centimeters, that means our object is going to be right here. And it says it's 3 centimeters high. So the scale that you use for the vertical axis does not have to match the scale that you use for the horizontal axis. So although each of these are 10 centimeters, I can say, okay, 3 centimeters is going to be 3 squares. That's perfectly fine. So once you've done this, now you're ready to draw the 3 rays. This problem is asking about the image location and magnification. We're going to do this using the ray diagram since I provided the paper. We'll also do this using the equations so we can see that they'll give us the same answer. I just like to do this diagram because the numbers come out nice and neat and easy to see. So let's go ahead and look at those rays here. The first one is going to be parallel to the optical axis. You always have to start it at the object, the tip of the object there. Make sure it's nice and horizontal. And then as soon as it hits the mirror, then you're going to make it reflect. So right at that location where it hits, it's going to reflect through the focal point. And when I do this, even if you're using a ruler, your ray can easily get off. See right here how without really being careful, I already know that my ray is off. The reason I know that is because what I do is I count the squares. I know I'm supposed to go through the focal point here. So I know it's supposed to go down 3 and over 5. If I go down 3 and over 5 here, that means that the ray should hit that intersection here. But the ray was a little bit too high, so I just like to go ahead and count those squares to help me draw the ray, even when I'm using a ruler, because it's very easy to get off. So now I've counted the squares down 3 over 5, just keeping the slope of that line, so that I know that my ray is accurate. So that's the orange ray that is parallel to the axis and reflects through the focal point. The second ray is going to go down through that focal point, so it always starts at the tip of the object here. It's going to go through the focal point, and as soon as it hits right here, then it's going to reflect parallel to the axis. So I'm going to draw that right there. Then I'm going to draw another ray that's going to be parallel to the axis. So hopefully you're following along, you have some graph paper, and you're able to get the same diagram that I'm getting. So this is going to be our purple ray here, that is focal point and then parallel. There we go. And then the last ray is going to be through the center of curvature and reflects right back on itself. So you start that ray at the tip of the object, and then you make it go through that center, and if you're counting the squares, it should go through this point here, because what I'm doing is I'm going down 3 over 5, down 3 over 5, down 3 over 5, so that's how I know exactly where it's hitting the mirror. And then as soon as it hits the mirror, it's going to reflect back through that center of curvature. So basically you're just extending that line that you were drawing. So this is the blue ray over here, the third ray. So we've drawn our 3 rays, and then the last step is to see where these rays are intersecting. And you can see I did a pretty good job here because they're all intersecting at the same point. That's where the image is going to be formed. So the image will always start at the optical axis, and then it's going to go straight down to where the rays are intersecting. So that's about all for this diagram here. So we can look at it and see that our original object was 3 squares high, and the image is about 1.5 squares high. We can also see that it's inverted, and we can see also where it is, right? The focal point was 10 centimeters, so it's halfway in between to the center of curvature, so it's 15 centimeters. So we can get all of our information just by looking at this ray diagram. What we just saw is that the Q, the image location, is 15 centimeters. It's in front of the mirror. That's positive. The magnification is approximately -1/2 because it's inverted. That's the negative, and it's half of the height of the object. So the last thing we want to do is go ahead and use the equations to get the exact same answer. So the first thing we want to do is use the mirror equation to get our distance q. So the mirror equation says 1 over p plus 1 over q equals 1 over f. We can use this to solve for q. Once you've done this a few times, then you might actually even memorize the expression that we get for q. So what I do is I want to isolate the 1 over q, so I'm going to subtract 1 over p from both sides. And then in order to subtract these two fractions, I want to have a common denominator. That common denominator is fp. What that means is that I must multiply this fraction by p. So multiply the bottom and the top by p. 1 times p is just p. And then this fraction, I want pf to be the denominator, so I multiply the top and bottom by f. Now that I have a common denominator of fp or pf that's the same, now I can subtract the numerator. So I get p minus f over pf. Or fp, but I prefer to leave it as pf, so it's easier to remember. And the last step, well, this is 1 over q is equal to this. So if you flip it, take the reciprocal of each one, then you get that q is equal to pf over p minus f. So sometimes students use this so much that they just kind of have it memorized so they don't have to solve for it every time. And now it's a lot easier to put in the values. So p is right here, the object distance, and then f is right here, the 10 centimeter focal length. They're both in centimeters. You don't have to do any conversion of units. So we're going to multiply 30 times 10, and we're going to divide by 30 minus 10. So you can see that you get 300 over 20, which is equal to 15. So you see how the ray diagram gives us the same thing as the mirror equation. And then finally, we need the magnification. So the magnification equation says that the magnification is -q over p. So we're going to use the 15 that we just found over p, which was 30. So you can see the centimeters actually cancel out. Magnification doesn't have a unit, and we get the -1/2.